Hello there. Ever since I've owned a 3D printer, my go-to filament was always PETG. The reason was, why pay for PLA when you can get toughness and high temperature resistance for the same price? Yeah, stupid, I know. And all this time I've been having a complicated relationship with PETG. And by complicated, I mean it's been producing prints that look like they were made by those 3D printer pencils. Let me show you what I mean. There's this bottom part of a Gridfinity box that decided to warp so dramatically it now resembles a rocking chair. Next, feast your eyes on this masterpiece. This is what happens when my printer decided to knit a sweater mid-print. And finally, this cover for my Raspberry Pi home server. Now, I don't have that type of OCD where I lose sleep over a crooked picture frame. And don't get me wrong, this is still functional, but I could not stand looking at it as is. So today we're gonna fix all of this. First things first, I grab one of my Overture PETG spools. Now, before you say,
"But I don't use Overture,"
hold your horses. This process works for basically any PETG and PLA brand, whether you're Team Overture, Bambu Lab, or that mysterious filament you bought on sale and can't remember the name. These steps are your new best friend. Here's where most people make their first mistake. They ignore the sticker. Yep, this is actually telling you something important. Usually the nozzle and the bed recommended temperatures are mentioned on the sticker. For me, the nozzle temp is between 230 and 250 degrees Celsius, and the bed temperature between 80 and 90. This is our starting point. Okay, let's hop onto our computer. Doesn't matter if it's a Mac, PC, or that ancient laptop you refuse to upgrade. We're going to open OrcaSlicer, and I can already hear some of you saying,
"But what about Bamboo Studio?"
Look, I tried both for months. Bamboo Studio is fine. It's like that reliable friend who shows up on time but doesn't bring much to the party. OrcaSlicer, it's like that friend who's not only showing up with snacks but also has a toolkit, jumper cables, or somehow knows how to fix your Wi-Fi. It's free, it's open source, and it has built-in calibrations that are going to save our bacon. So, assuming you've already got OrcaSlicer installed and connected to your 3D printer, if you haven't, there are plenty of tutorials out there. Let's start with the first step. We need to pick a PETG profile. I'm going with Bamboo PETG Basic, but you could also pick generic PETG. They will both get the job done. We are going to customize it anyway. But here's the important part. Make sure you select the right nozzle size. Currently I'm using a 0.6mm nozzle, but if you're using 0.4, 0.2 or any other size, make sure you select the right one. And here's the thing that might hurt your brain a little. You'll need to do this whole calibration process for each nozzle size you plan to use. Sorry to disappoint, but trust me, it's worth it. Same goes for the different brands and types of filament. It might work with these Overture settings, but there's no guarantee it will look as good. And if you want to print with PLA or TPU, well, that's a whole different ballgame with different temperatures requirements. Okay, so we've picked our profile. Now I'm going to click the edit because we need to make this profile actually work with my setup, not some theoretical perfect setup. Since I'm using a Bambu Lab A1 Mini, my bed maxes out at 80 degrees Celsius. The sticker on the spool specifies between 80 and 90, so I'm maxing out my printer at 80 degrees for both first layer and other layers. Make sure you're editing the right build plate. Mine is the texture PEI plate. If your printer can go higher, you can bump it to 90 degrees or play it safe and go somewhere in the middle. There are some bed temperature calibration prints out there if you want to get really fancy with it, but personally I have not had any issues with bed adhesion yet. And as long as you keep your plate clean and free of hand oils, you should be good too. Don't forget to save this profile with a custom name so you know it's yours and not just another generic profile. And now for the fun part. In the top toolbar there's a calibration menu that's about to become your new best friend. It's got more options than a fancy coffee shop, and they're all documented on Orca's GitHub page. If you're the type who likes to read the manual first, you can also find a link to it in the video description. We're starting with a temperature calibration. It automatically sets the start and end temperatures based on what filament you choose to test this on. We start high because higher temperature means better bed adhesion. We don't want our print doing a dramatic exit halfway through printing. Alright, it's done. Time for some quality control. Looking at this tower, I can see that at 250 degrees there are some obvious plastic hanging. 240 looks slightly warped, but I think 245 it's looking pretty sweet. So back to our custom profile settings. I'll keep that first layer at 250 for that good bed adhesion insurance, but set other layers to 245 for cleaner prints. Save those changes and let's move on to the next step. Now let's tackle the stringing issue. For this we're using the Retraction Test from our calibration menu. Retraction is basically how much the printer pulls the filament back before moving to a new location. Usually you'll want this somewhere between 0.1 and 0.5 millimeters, but let's test from 0 to 2 millimeters with 0.1 millimeter step, because why guess when you can know for sure? Okay, perfect. Now let's examine our test subject. The top part looks like String City up there, but as we go down, it gets cleaner and cleaner. See these little grooves on each tower? Each groove represents our 0.1mm step, so we can count up to find the sweet spot. For me, it looks like good around 0.4 or even 0.5mm. Back to our profile settings, under the Setting Overrides tab, I'm changing the retraction length to 0.4mm and saving the changes. Okay, last calibration, I promise. This one's called Max Flowrate, and it's all about how fast we can push our printer without screwing up everything. I'm leaving the defaults, 5mm for start volumetric speed, 20 for the end, and 0.5 for the step. This is going to gradually increase the print speed until we find a breaking point. Okay, let's see the results. Well, that's actually perfect, which means we did not find our breaking point yet. Time to push harder. Back to max flow rate calibration. Let's bump the start to 15mm and to 50 and step to 1mm. Round 2, here we go. Houston, we found our breaking point. Time for some precision measuring. Every 3D printer owner needs a caliper. If you don't have one, you're not really living the 3D printing life. I'll link an affordable one in the description. Measuring from the bottom to where it started to fail, you'll actually want to go a bit lower than the breaking point, just to be safe. For me, I'm seeing somewhere between 13 point something and 14 point something. So let's meet in the middle and call it 14. Now I need to convert this to max volumetric speed using a formula I'll put on the screen. Pause if you need to do the math. My result is 29mm, so that's what I'm setting. Now, some of you with attention to details might have noticed that I have been calling this my overture profile, while the vendor still says Bambula. My inner organizer is cringing too, so let me fix that and give this profile a proper name and vendor designation. There, that's better. But wait, there's more. Let's step it up a notch. You see, PETG is basically the diva of 3D printing filaments. It's high maintenance, it's particular, and it absorbs moisture faster than a sponge. If you're like me and you've had one spool sitting around for 6 months without proper storage, you're going to need to dry it before printing. Now, you could spend hundreds on a fancy filament dryer, but let's be honest, if 3D printing is your hobby, not your business, there's a much cheaper way. Take the box your filament came in, cut it to make a half box, tape up the gaps, punch some holes in the top for airflow, heat your printer bed to 60 degrees Celsius, put your spool on top, cover it with your DIY drying box and leave it for about 6 hours. Okay, this is an important safety note. Do not leave this unsupervised. Don't go to sleep, don't leave the house, don't get distracted binge watching Netflix, stay home and stay alert. I ran mine from 10 AM to 4 PM while working from home. Let's test if it made a difference. I printed this Orca string hell model both before and after drying. The before version looks like, well, string hell. Lots of stringing, pretty messy if you ask me. The after version, still some stringing, but much better. I even went back and adjusted my retraction length from 0.4 to 0.3. And I'm not sure, but I think I slightly got better results. Yeah, this whole process is just trial and error. Okay, so there you have it. You've probably invested good money in your 3D printer and filament, so it makes sense to use these free methods to actually get good results from them. None of this is rocket science, but it does require a little patience and willingness to test things properly. I hope you got something useful out of this video. If you did, smash that like button and subscribe for more videos like this one. Also, if you want to support my journey from complete noob to hopefully one day expert, there's a buy me a coffee link in the description. You'll also find the links to all the tools I mentioned. Some are affiliate links, some aren't. Use them if you want to, no pressure. Thanks a ton for watching and I'll see you in the next one. Bye!